Alright, hello everybody, and welcome to the first video of this channel. Welcome to this channel. By the way, it's me, GD Tank 4. This is the second channel I've made for educational purposes that explain basically like science and whatever type of stuff like that. So, today I'm going to be showing like how people don't know what they sometimes don't know how to use this symbol is this. What is this, you might ask? Well, this is called the sigma. I know my writing is bad since I'm on my tablet right now. So this is basically sigma, or possibly known as sigma notation. So I'm gonna erase this entire thing. I don't know how to use this yet. So I'm just gonna, I guess use an eraser. Hold up. Where is the eraser? Do I have to look for this? I think this is the eraser. Yep. And there goes that. Alright. So basically, the way you use is like you want to like make a set, right? Like 1 plus 2 plus 3 all the way to 100. And then but you have to use these dots, and then you have to do plus 100. But scientists and mathematicians figured a way to get rid of this dot 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 thing, and how we could replace this. And instead of writing all of this, we could use something known as sigma notation. So this is basically where the usefulness of sigma comes in. Sigma usually is used when we are classifying a set, like your, for example, if you want to write the set I just mentioned, we're gonna have to first look at all of the parts of sigma right over here. So you have policy to write a number over here, x. I'm just writing it like that. You write an index down here, I equals x, or and whatever, and then there's a rule here, x. But well, I'm not classifying it right now since we don't know what these values are. One, so the value on top, the value on top is where the set is going to end. Like for example, for the set I just mentioned, it's going to end at 100. The next is the index, the what the value is going to be, and it grows bigger. So we started at 1 at the set, so I equals 1, and then at the rule we just add I. So basically the reason we add I in the rule only because we keep adding I, but you say I equals 1. So 1 plus 1 plus 1 is not valid to 1 plus 2 plus 3 plus 4 until 100. Actually, with every increasing step, I changes from every step like 1 into 2. It adds 1 to itself, so like this thing equals to 1. So this is the first term. This is the first term. And then 2. This is the second term. And then this is 3. This is the third term where I keeps growing. So that is basically how we use sigma notation. Now I'm going to plot a few more complicated versions of this. For example, if we want to use fractions on sigma, so we're gonna have to equalify what I'm going to do right here. So instead of I, we're using k, and then it equals to 1, and then the endpoint is k upon 20. So, and the rule is k upon, you know, what else would you think of? 20. So, this will translate to, instead, we don't have to actually write this, but if you want more clarity, then you can write it. So, what this basically translate is to, in the first term it is 1 upon 20. In the second term it is 2 upon 20. In the third term it is 3 upon 20. And you can simplify this like, I don't know, 1 upon 10. But that just makes it even more confusing, and that is not appropriate to use it since 1 is already here and it should not be here since k always increases. The index always increases each step, each term, each step. My god, so the index always increases with each term. With each each term. So we're gonna get rid of this entire board over here. And now we're gonna get a few examples of sigma. So what we can also do is use decimals. So you can also use decimals in sigma. So for example over here, I can add 2 on top of here and the index will equal to 0.01. Now you have to remember this. The value is I. So what does this translate to? 0.001. No, not 0. I have to erase that. Alright. 0.01 plus 1.01, since I always said that adding 1 to the index. But no, that is not how things are. We add 1 to every term of where a value is in the index. So the only value we can see here is 1. Is 1. So the next value is going to be 0.02. So this will keep on going until it reaches 2 or 2.00, which is a pretty long chain, like 200 year digits, for example. So you may be asking, how will this ever be useful? Well, it becomes useful when you're making sets and you have to add them individually. You know, like, I don't know what question to come up with, but it was like we have to like figure out a sequence. So we have to figure out a sequence using sigma. And the general equation that I came up was, alright, we're gonna scrap this up. The reason I'm scrapping, what even is this? Nah, that's a tin eraser. So the reason we use sigma is to like use it in adding different things and numbers. For example, if we want to know what is the summation of all of the following numbers, like for example from 1 to 100, what is the summation of all of these? Now for this we use sigma. That's why it is so common that you see sigma in many complicated pre-calculus questions. Now, it is not even that complicated. Sigma isn't complicated for you to know sigma. Sigma, people think it is difficult, it is not understandable, but people don't realize how easy it is to understand sigma. It is just like it is only a Greek letter. You just make this and a number over here and an index, any number, and then add a rule like I plus x or whatever. It's not. I guess I'll make this y. Like you just have to think. You just have to use your beautiful brain to understand sigma. You know, if you want to understand sigma, then you gotta watch this video. Well, you already did, so props to you. And so now, instead of dedicating one video to sigma, we're also going to learn about, graphs. Now, I want my graph. Like, I want a normal graph. Do I have to make a graph? Hold up, this is becoming a little bit too difficult. Alright, I can't make a graph over here. So basically, a graph is. I did not want to do that. Can you get out? Oh my god. Alright, so basically, a graph is like. Can this go away? This won't go away. Anyways, basically, uh, why can't I freaking okay? I have to. Why is this like that? Now I can draw. What the hell? Alright, so basically, a graph. So basically, I've said this 1 million times already. A graph is like this. This is the x-axis, and this is the y. Now this is the y-axis. Now the x-axis and the x-axis and y-axis are completely opposite. As you can see, the y-axis is like this single file line, and the x-axis is this single file line. So the way this works is like there are numbers like 1, 2, 3, 4, 5, 6, 7, and then there's numbers like over here and over here and here, everywhere basically. So it to form like such a complicated equation with just for single point like 2, 3, or something like that, you have to use curly brackets too, by the way, to express this stuff. So yeah, for defining a single point, that's way too difficult. So we're going to be understanding what this means. So basically how this works is that there are grids like 1, 2, 3, and 4, which all have different things. And as you can see, in any grid there are like lines like this that go through the numbers, by the way. And then there's another line. There are more lines like this. Now for defining big a point over here, like for here example. So this is 0 and this is 1, 2, 3. So this goes with 3 and 3. So first you have to put in the x-axis. Why did I make such a bad curly bracket? So first you're going to define the x-axis, which is 3, and then the y-axis, which is also 3. So yeah, that's how you define a point in a single grid in the x-axis and the y-axis. So basically that's all I wanted to teach today. Thank you guys for listening and see you guys next time. Bye bye.